Welcome to Elevate 2022. I'm John Strano, and this session is Where Did My GLV Go? Git SCC, Sync, and Rebase. I am the sole author of the content of this presentation, and Appian makes no warranty of any kind, either express or implied, including but not limited to the implied warranties of merchantability, fitness for a particular purpose, or non-infringement. Appian assumes no responsibility for errors or omissions, which are solely mine. I'm John Strano, and I've been around PowerBuilder for a while, since version 1.0b, and I've done quite a bit with PowerBuilder. I've been an instructor, a developer, a systems architect, a technology evangelist, so-called, glorified pre-sales software engineer, as it were. I am a member of the Intertech consulting team. Intertech is the oldest and largest consulting firm specialized in PowerBuilder tech in North America. We focus on architecture, consulting, education, programming, project management. We can take care of all your enterprise solution needs. Give us a call. Okay, what is our agenda for this session? We'll briefly cover what Git is as far as source code control, and we'll talk briefly about Git latest version, or the so-called GLV, in Microsoft's source code control interface. And Git, is it really distributed or is it really centralized? We'll talk about one branching scheme for the purposes of providing context for the demo, and then we'll talk about rebase being Git's so-called GLV. And then when do you rebase? When does this become the most useful tool? No walking in Git. Yeah, we'll talk about that and how to pursue best practices to keep you out of from experiencing an undesirable scenario. And then we'll talk about the rebase recipe, the step-by-step how-to, a demo, and then Q&A. So yeah, so many, even now, many development teams I've come across are small enough that you yet to experience the need for source code control, but maybe it is time to provide an infrastructure for growth so that you're not caught flat-footed when that growth does begin. We will intermittently touch on basic SCC concepts, but again, for the most part, this being a primer for SCC is beyond the scope of this session. So, Git, what is it? Git is a source code control platform. It's based on the concept of system-wide distribution, meant to be peer-to-peer in theory. Although, most folks, most teams do use a centralized remote server. I mean, think about TFS or DevOps or other platforms, but it's not strictly required. Again, beyond the scope of this session, but do look up Git daemon as one example of how it can be utilized as peer-to-peer, as opposed to what we conventionally refer to as remote versus local repositories or repos. Okay, should I use Git for SCC? That's entirely not up to me. The discussion of Git versus SVN and other latter-day platforms is up to you and your team to evaluate. We assume that you have made the decision to pursue Git at the beginning of this session, and we'll show you what the ramifications are for that. Now, GLV, it's a feature of the Microsoft Source Code Control interface, and GLV, as we know it, does not exist in Git. As a matter of fact, you do need to get used to not having the MSSCCI around for too many more years. So again, you want to provide for your future. You want to future-proof as much as possible. So let's go ahead and take a look at this so-called equivalent of GLV in Git. So again, refer to the Git daemon command line just as an illustration that Git at its heart was designed to be peer-to-peer, not remote versus local, but it is designed to have distributed repositories. However, I have yet to not utilize a centralized remote repository for Git. Local developer modifications are pushed. We don't say upload, we say pushed up to the remote repository or repo. And a word about branching. Those of you who have been utilizing source code control, yes, branching is at the heart of Git as well. You know, multiple branching schemes, you can use them with Git. It gives you that sort of flexibility, that plasticity. But the discussion of the various branching approaches is also beyond the scope of this session. It might be arguably deserving of its own session or 6. But we'll assume, for the purposes of our discussion, that there is one development branch up to which developers push and or merge their own feature-based branches. So, off of development, yeah, we'll assume that there are multiple feature branches, as I'm going to call them. And here's just one scheme, one graphic. Forgive me, this is not my graphic. I can't take credit for it. It is a nice one. I wish I'd had the presence of mind to preserve the credit for it. But look at the development branch. That's what we'll utilize for our discussion today, as well as within our demo. There will be one development branch off of which each developer, multiple developers, can branch their own sub-branches, if you will, for one branch, one feature branch per feature, and keeping it that granular. We do recommend that kind of granularity. So in Git, we say that the code is pulled down, not downloaded, but pulled down to the local Git repo. If we were being strictly peer-to-peer, we'd say it'd be pulled over to our developer repo, but down that road lay madness. Modifications, you as developers will develop it locally within a local repository. So let's just start using that convention. You and I will talk about remote versus local repositories. Modifications, once you've made them, are pushed up to the remote repository. We assume that you already have had a primer on Git and utilizing it with PowerBuilder. I highly, highly recommend Miller Rhodes, my fellow Intertech Consulting team member from the year 2020. Look up his session. It was an education for me back when as well. So, Rebase, it's Git's so-called GLV. In fact, here's the best illustration with clarity that I have come across to date. Again, this graphic is not mine. Hats off to whomever it was that I didn't have the presence of mind to give credit to. But we see here in the master branch, we have the blue dots representing change sets. And the amberish circles are also meant to represent change sets. But we see that at some point, we're going to branch our feature branch off of the master, or in fact development. And then as time goes on, our fellow team members, our fellow developers will start checking in or pushing up and making modifications to the master or development branch as time goes on. And then the head of our feature branch is left behind. Let me go back there. Is left behind. So in fact, we're going to rebase by assigning a future or subsequent change set as the base of our feature branch, hence rebase. So when do you rebase? Well, certainly after you fully unit tested your local enhancements, after you've pulled down your feature branch that was created up on the remote repo, and then when you're ready to test it with other team members' modifications to make sure that yours and theirs mods do play nice at the playground. And certainly, please, certainly rebase before you push your enhancements to the remote repo. There's nothing more painful that I can imagine in a Git scenario than having to resolve merge conflicts out on the server. Make sure you address merge conflicts if and when they occur in your local repository. All right, now, perhaps I don't want to kick this horse, be it dead or otherwise, but there is no locking in Git. At its heart, it's meant to be peer-to-peer. So the lack of checkout and the implicit lack of locking means that, yes, merge conflicts are possible. Please do follow best practices to avoid them at all costs. I will show you one way to be able to, once you've ensured they will only be recognized locally, as you can pursue then resolving merge conflicts with impunity. I will show you in the demo how to do that. All right, so the first step in the recipe, and I'm going to call it a recipe, is to back up, back up, back up. You'll see when we get to the demo, you'll see in my Windows Explorer, excuse me, you will see a backup of the entire folder. It is so nicely encapsulated. Your local repo is so nicely encapsulated with your workspace. Do back it up first in full. This will give you, yes, manual, so to speak, but a pain-free reversion point. There is a lot of stuff in that local repo, not just your PowerBuilder pibbles, but all the source code definitions in the ws_objects folder. Again, I would refer to Miller Rhodes' session for a discussion of ws_objects, or the stellar documentation that Appian has provided. There's the Git indexing, there's other metadata that I won't go into, but it is so nicely encapsulated. Just back up that folder. And then pull down the development branch, or whatever you folks, your team has named the branch, to which your team members have been merging their enhancements while you've been working on yours. And then perform the rebase using the Git GUI of your choice. I have, thank you, Don Clayton. He introduced me to this DevArt URL. I love this discussion of perhaps a dozen Git GUIs that can be on top of Git for Windows. Then you will reserve any merge conflicts that you find using the compare and/or resolution interface that your Git GUI provides. And then, yes, unit test all over again to see, even after the explicit merge conflicts have been addressed, just make sure that you operationally perform your unit, if not beyond that, your system test. And then push your conflict-free mods to the remote repository. I do highly recommend reading up on force with lease switch to your Git push. You may want to utilize a command line for this to push it up. Do read up on force with lease. Multiple entries and discussion threads out there. Here is one that I found especially initially helpful. It's Stack Overflow. All right. So the moral of the story, folks, do follow this procedure, or something that's perhaps even more detail-oriented. You do, at all costs, want to avoid a server-side merge conflict. You don't want to have the sort of thing happen in a shared environment. You want to make sure it happens in your local development sandbox. Please, please, please do yourself this more than favor. All right, now, resolving the merge conflict locally, it could become too complex or unwieldy to use compare and edit tools. Think about a data window objects class definition and the source editing. If you have performed that backup, you have the option then of using the IDE painters rather than editing source. If you've backed up before pulling down, before you perform the rebase on your local repo. If you can restore the local repo to before you found the merge conflict, you can then use the GL of the PowerBuilder IDE painters to be able to accommodate anything too complex for a text editor. And lordy, folks, it is also more than possible to corrupt a local repo. There is indexing, there's local tracking branches for remote branches. A word to the wise. Okay, now the demo. So let's look at our rebase demo, our Git Rebase demo. As a reminder, what we are going to do is to take our feature branch and the change set in the development branch upon which it is based and move its base to a change set that's later in the development branch that contains our fellow developers' latest modifications. Okay, here's the environment that I've created for this demonstration. I have 4 local Git repositories and 4 workspaces so that I could mimic 3 fellow team members' development modifications for this one application. And here I'm going to behave as developer 4, who needs to be able to get my fellow team members' modifications into my local Git branch. Let's see what I'm talking about. Here in the local repo in the workspace for developer 4, there are 2 local branches. Let me go ahead and pull up the switch branch window. So we see that, yes, we do have the remote or origin branches reflected here in the local tracking branches. But more to the point, I have 2 local branches in my local Git repo. One is for myself as developer 4 and the modifications that I'm creating, and the development branch, the local development branch that I have, into which I have pulled down all the other team members' modifications. Let's go ahead and look at what my fellow developers have actually performed in the way of those mods. So I'm going to open up the About window. And lo and behold, here are these highly critical modifications that my team members have made. Let me switch over to the local feature number 4 branch and see what I need to do. Okay, more to the point, I don't know what my fellow team members have been working on. Because this is Git, there is no locking, so hopefully you folks will have followed best practices and keep a roster of which class definitions that each of you was working on. But let's go ahead and look at the About window here. I hear that there have been modifications in our stand-up meetings to the About window, and I see that I don't have those mods here in my local branch. How can we address this? Moreover, how can I make sure that all those modifications are added to the modifications I've been making to feature branch 4? Let's go ahead and make some gratuitous modification here. There we have it. Let me go ahead and save. Now this modification has been saved only to the PBLs. What I need to do now is to get my local gratuitous modification that we see has not yet been committed to the local repository. Let's go ahead and do that. I'm going to commit my feature number 4 branch. Okay, so there we have it. Everything has been committed to the local repository in the way of my modifications, but how do I get developers 1 through 3 modifications into my local branch feature 4? I'm going to close the PowerBuilder IDE. I'm going to change back over to the Explorer, and I'm going to right mouse click on my local repo for feature branch 4. I'll choose Tortoise Git, and you may use any number of Git GUIs. There are plenty of them out there, but for demonstration purposes, I like to use Tortoise Git. So let's go ahead and choose Rebase. And for the branch, feature 4, and for the upstream branch is going to be development. And I'm going to click on Force Rebase and pick all. And we see that there is a modification in the splash window in this feature 4 branch. So let's go ahead and force that rebase. And we see that that's proceeded without error to completion. And we'll close. I'll reopen the PowerBuilder IDE. And I'll open up my Feature 4 workspace. And I see that my Feature 4 local branch is selected. Let's go ahead and open up that About window. We may see something surprising. So there it is, but where are my fellow team members' modifications? Well, the rebase procedure that we utilized Tortoise Git for only acted upon the source files in the local Git repo, and they only exist in those ws_object folders and files. What we need to do now is to refresh our PBLs, utilizing the source code, especially the class definition source codes that have been changed through the rebase procedure. Let me close this. And I'll choose refresh. Keep an eye on the output pane, and we see that it is regenerating the W About window. And let's go ahead and open it back up. And so there we see that my local branch for Feature 4 has been fully rebased with my modifications from my fellow developers. And if we open up the splash window, we see that my myriad plethora, if you will, of modifications has also been kept into place. So now this is an integrated development environment that is up to date. And so this, the rebase, is the Git equivalent of our Get Latest Version, or GLV. Now, our team can show you how to achieve adequate governance by pursuing due diligence, by adhering to best practices. But let's say that you know, since Git does not have locking the way that MSSCCI allows, there's going to be some merge conflicts at one time or another. Simply put, two team members may end up modifying the same class definition that arises in conflict. How do we deal with that curveball in a PowerBuilder Git context? We see here that I have intentionally, as developer 4, created a modification to the same class definition that you and I know, is going to be in conflict. Other team members have modified it. As a matter of fact, those changes we've seen in my local development branch, in my local repository. Let's go ahead and now that it's been saved to the PBL, it's not yet been committed, as we can see. Let's go ahead and commit to my local feature branch in the local repo. Okay, so that modification has been committed to the local repository, so it is in Feature 4 branch's local repository, that source file. Let's go ahead and, I don't like to use PowerBuilder IDE. I don't even like to have it open at the same time as Tortoise Git, perhaps just a personal superstition. But now that we have the IDE closed, let's go ahead and right mouse click on where the local repo is for Developer 4. And what we're going to do is choose Tortoise Git, and this should be familiar by now, and choose Rebase. And I'm going to choose the local development branch as the upstream. I'm going to say Force a Rebase, and I'm going to click Start Rebase. And we see that the GUI and, in fact, the foundational Git for Windows has recognized that there is a conflict. So let's go ahead and select that class definition, that source file, and choose Edit Conflicts. And again, you and your team may choose something other than Tortoise Git as your Git GUI. There are plenty of them out there, but this is what will it look like using the compare and edit feature for Tortoise Git. Let me go ahead and I'll highlight those two lines from the development branch. I'll say to use the text block from the left before the right, and we'll see that indeed all three of my academically created developed modifications have been put into the merged source file, the class definition for the About window. I'm going to go ahead and then, so I'll use, just to resolve the conflict for this remaining red line, I'll use from the left. So there are no more conflicts left to be resolved, and I'll mark everything as resolved. And I'll go ahead and save this source file. And now I'll go ahead and commit that merged file, the new file, and commit it to the local repository for the branch. And that's done. And after opening up the PowerBuilder IDE once more, I am verifying that indeed the current branch in the local repo is my feature 4. And I'll go ahead and you might be able to anticipate at this point what we're going to see when we open up the class definition. And just the conflict. So what do we need to do next? Yes, we do need to refresh the PBLs from the source files in the local repo. And from the output pane, we do see that there is some busyness needed for w_about.srw. And let's go ahead and open up the About window in the painter. And there we see not only have we resolved the merge conflict, but all the developer's modifications have been implemented here in this particular branch. Do take advantage of the treasure, the boon, if you will, of the Appian community. In addition to discussion threads to find that person who is the future version of you who solved today's problem, but 6 months ago, do look for them out there on the discussion threads. Look for the tutorial videos. It's just chock full. And thank you so much for your time and your attention. And now for Q&A.